Okay, so on Friday, we took 13.1 notes, and we talked about the different parts of a quadratic function, including the axis of symmetry, the vertex, the parabola, and the minimum or maximum. And we need all those to help us graph. Today, we're going to kind of learn a shortcut. And if you looked ahead in the notes, you might have seen this at the bottom and not understood what was going on. So we're going to talk about this here real quick. First of all, it's called the 1A, 3A, 5A pattern. Now, the key to this is that A. Remember, in all our quadratic equations, we had our basic form of ax squared plus bx plus c. This is where we get our a from. So whatever number is in front of our x squared. So for this first one, we're going to just assume that our a is equal to 1. So our equation could be 1x squared minus 5x plus 2 equals 0. We're going to assume the a is 1. So we use the 1a, 3a, 5a, and what that means is 1 times a, 3 times a, and 5 times a. So in this case, 1 times a would be 1 times 1, or 1. 3 times a would be 3, and 5 times a would be 5. Now when looking at our graph, our first thing we're going to have to do is find our vertex, regardless. Well, once we have our vertex, then we use the 1a, 3a, 5a method for the points. And what you're going to notice is that the first one, 1a, we go out 1 from the vertex in both directions, and then the number we have tells us how high or how far up we go. So in this case, since it's 1, we go up 1 step. Then we go out again 1 step, and then this number tells us how high we go. So that's a 3, so we're going to go up 1, 2, 3 for our next point. 1, 2, 3 for our next point. Then we go out again another step, and then this last number tells us how high we go up from that, and so you guessed it, we go up 5. So 1, 2, 3, 4, 5. And we do it on both sides since a parabola is symmetrical through the axis of symmetry here. So we do the same thing on both sides. And so that's how we use the 1a, 3a, 5a method to graph our graphs. The next one says, well, what if a is equal to 2? Well, easy enough. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. Remember, 1a, 3a, 5a. So now, let's take a look at our graphs, and we're going to go up 2, then 6, then 10. So here we go out 1, up 2, out another one, up 6, and then out one more, and then we'd go out up 10. But in this case, up 10 gets us out past the graph, and so we didn't use it. The same thing works with a negative. What if a is negative? So for example, we have negative x squared plus 6x minus 8 equals 0. Well, in this case, our a is equal to negative 1. So this time, our 1a would be 1 times negative 1, or negative 1. Our 3a would be 3 times negative 1, or negative 3. And our 5a would be 5 times negative 1, or negative 5. So now, if we look at our graph, again, we go out 1, but this time it's -1 step. We go out another one, and again, this time it's a -3 step. And then we go out another time, and this time it's a -5 step. So we go down. And again, we do it on both sides. So this helps us to graph a quadratic pretty quick. So now let's take a look at a table. So now if we filled it in, if it's telling us our x is -2, we're going to substitute in -2 squared minus 5. -2 squared is 4. 4 minus 5 is then -1. F of x equals -1 squared minus 5. Well, -1 squared is 1. Minus 5 is -4. F of x equals 0 squared minus 5. 0 minus 5 is -5. F of x equals 1 squared minus 5. 1 squared is 1 minus 5 is -4. You can see how now all of a sudden it's starting to come back up. And so if you think about this last term, since it's 2, it matches up with the -2. And so more than likely, we're going to get -1. And you can see it's symmetrical. It goes from -5 to -4 to -1, then to -5 to -4 to -1 the other direction as well. But we can do this just to be safe. F of x equals 2 squared minus 5. 2 squared is 4. 4 minus 5 is -1. So if we were to graph this, we'd come here. We have -2, -1. We have -1, -4. We have 0, -5. And then 1, -4. And then 2, -1. And we can kind of see our graph here and what it would look like. Again, our axis is symmetry. Well, let's start with our vertex. Our vertex is then at 0, -5 is where the curve is. Our axis of symmetry is an imaginary line going through the vertex, vertical line. So in this case, x equals 0. We can see it opens up. It makes our vertex the lowest point. So it's a minimum. And then what is the pattern? Well, remember, our pattern is 1a, 3a, 5a. In this case, our a is equal to 1. So 1 times 1, 3 times 1, and 5 times 1. So our pattern is 1, 3, 5.